This is Henk Akkermans and this is Smart Asset Management Lecture 8, Design for Maintenance. Section 4, Circular Design in Public Infrastructure, a new challenge. So we've looked so far at various types of assets. We've looked at fleet, at mobile assets, trains, various machines. Now let's look at that huge challenge that society has ahead of it, which is its public infrastructure and the need to renovate and redesign that. That also is a huge design for maintenance or design for life cycle challenge. And what is also big there is the change in what is being asked from the people in this industry. For instance, from the engineers and the engineering firms that typically design these infrastructures. Very bluntly put, the question that used to be asked to them was build something from steel and concrete to, thrive in an adaptive ecosystem. So in the past, you have to get people from A to B. So this could be a road or a bridge or a lock or a canal, whatever. But cost was key. The lowest price usually won the offer. So there's a lot of focus on design build cost, but much less on the operating cost and even far less on the maintenance cost in the past. We don't want to waste the taxpayers' money, usually means today's taxpayer or yesterday's taxpayer, so the current focus. There wasn't really a long perspective of a strong focus on the end of life, because the end of life it's after we are all done. There is many steel and concrete in particular may last a century, many decades indeed. So there was not really focus on that circular idea and the environmental constraints. So the CO2 footprint for all that concrete and steel. It's mostly irrelevant, not really a main point of concern. Also, the energy usage of all the installations and systems around that infrastructure wasn't really a main point of focus. And digitization was basically absent. Concrete and steel. What do you mean digital? The relationship in the infrastructure between the asset owners that asked for the new infrastructure and the engineering firms that designed it and the contractors that built them, are pretty competitive, price driven, and not really aimed at collaboration. More keep your cards in front of you. And that moves then towards an adaptive ecosystem. And some of these quotes I have from an ongoing research project together with several of the parties in this infrastructure. The function remains a guaranteed mobility, but the infrastructure is even more important. It's always on, it's always available, and that availability now is much more recognized. Can also be done by smart maintenance, by smart services, what have you. So the use of digital information to actually make sure that there are no, there's less maintenance, and when the maintenance is done, it's just on time. Adaptiveness becomes much more a focus. We now do no longer assume that what we build today will have the same function in 20, 30 years ago. We actually expect that people's needs, for instance, the needs for transportation, will change. You even see during this COVID-19 crisis that how much people think that they need to travel back and forth to work can become very different in the short term. So perhaps the capacity is less, perhaps the capacity is more. Is the capacity different? If the electric bikes become much more popular, especially in a flat country like the Netherlands, what does that do for the need for public transportation of students, for instance? So many uncertainty that it's certain, that is different. So you have to build today, design today for something that can adapt in the future. And not very difficult, it should be easy. And at the same time should be robust for a whole variety of futures. It should also be sustainable, and sustainable is much more important now. Well, of course, one way of it being sustainable is that it is adaptive. If the infrastructure turns out that it's no longer needed because there is no demand for it, that's also a waste of everything. but also the CO2 footprint, the energy usage, the reusage of materials and elements at the end of life, and standardization of these construction elements so that you can have common spare parts. So just examples of sustainability, how it translates in many different specific aspects. One person who really understands this very well is Jacqueline Eijer. She is the head of Dutch, the association of the engineering firm, the NL Ingenieurs. And she was originally trained not as a brick and mortar, as a steel engineer, but much more in the ecological area. And that comes in quite handy for now when the reality is much more that of a biological metaphor, so of an ecosystem, rather than still of steel and concrete. So this is from a presentation that Jacqueline gave at the last World Class Maintenance annual event, where she stressed that our planet is full of all sorts of regulative cycles. In biology, but also in ecology. This is the great circular cycle of water from the ocean to the land and back again. But also many cycles, of course, in nature, where there are these food cycles where in the end what is being eaten ends up being eaten itself. What's being eaten eats itself, and vice versa. So cycles are all around us. They're just not so much in our physical infrastructure. And that circularity needs to be much broader, permeating the whole design business, basically. It starts with prevention, of course. Make sure that you don't do what you don't have to do, but it becomes much more into a positive thing. Can we prolong the lifetime? Sorry, the presentation is in Dutch, but I'll for the English speakers, I'll walk you through it. Prolong existing objects and make sure that the use of the existing building materials is better. But you can also say, hey, can we not design for multiple life cycles? Can we not think ahead of what will happen afterwards? Can we not develop more future-proof? Can we optimize our maintenance, and can we use sustainable materials? So it's much more from a let's not do things that we don't have to do towards let's do things that we could do. And if you then translate it to the practical, it's actually, you might get dizzy. It's almost an embarrassing abundance of opportunities that you have here. And this is just an artist's impression of the things that we Dutch can do around dikes. We can have different material at the seaside to make sure that we don't need so much of the cladding of the dike. We can have all sorts of monitoring, of course, to make sure that there's preventive maintenance being done on the dike structure. We can have alternative uses of the space in front of the dikes, not just sheep, but also solar panels. We can prolong this material. We can have natural green cladding at the dike. We can have all sorts of lifetime extensions by having smart additions to the sides of the water. So many, we can reuse the material. The story goes on and on. And engineers love doing this, but nobody ever asked it. Especially not the customers. And when the customers ask it today, do they really mean it? Or in the end they still mean, yeah, but it should be cheaper also. So there's all this opportunity, but how do you actually, what is actually working? And here Jacqueline again stresses the circularity, the feedback loops. We have to try out stuff and see how it works in practice. And what works in practice then gives us new ideas on how to do it better. And that's at the level of an individual infrastructure. But actually, there's a whole hierarchy of these, because what we try in one city, we could try in another. What we can try in one country, we can try in another. What we try in one domain, we could try in another. And so there are many feedback loops here at that hierarchy. And that becomes then the ecosystem. Where at the individual level, at the micro level, well, we can be very flexible, but the macro level, and this is in biology, that's pretty rigid. There are no such quick changes. There are changes in our ecological system as a whole, but they're much slower than what we can do as individuals. And communities in between are sort of in between. Now, the hierarchy, these layers are also there at the level of the city, at the level of the physical infrastructure. There also you have an individual, an area, a city, and a country. And again, there is this difference between the fluidity, you could almost say, of the micro level versus the rigidity of the macro system. So there is the hierarchy, but there's also then again the dynamics, the feedback loops. There are the relations again. Also in the city, people come together for a certain reason. When the reason is no longer there, the people are no longer there. So you have restaurants when there are people that either live there or work there, that come to eat there. When there are many restaurants, it becomes more interesting to go there to a place. So there are all these reinforcing feedback loops that actually make an ecosystem of a city a success, and the infrastructure is a crucial part there. Sorry about that. It's also true that many of these relationships are, there are tipping points in there. So things may go well for a long time, and then all of a sudden they go wrong again. So there is, in these dynamics, there are reinforcing feedback loops, and there are dynamics. There is even cascading effect. This picture then translates the triggers. I think a YouTube video where you see that the introduction of wolves in a certain area, in a certain nature area, actually triggered a whole cascading of events, which in the end changed the way that even the rivers were flowing because the use of the rivers was different. So there are really this system dynamics effects in infrastructure, and if we want to have circular design, we have to be aware of that. We cannot for one time put something of steel and concrete in an environment and then see and then expect it to work. No, it has to be in our circular thinking way beyond that fixed 3D model as it translates into something which is innate. These are living things. And that's also her point, that the city then really becomes an ecosystem, both economically and socially, but also technologically. Here's an example of how that then works in practice. This is a pilot, a field lab, as we do many in world-class maintenance. This is the lock at the water lock at Eefde, an area in the Netherlands where there's both an existing lock that needed to be renovated, and also on the basis of that, there's a design for a new lock. And there is a whole ecosystem of parties that together experiments in with many things around smart maintenance in this lock. So there is of course the Dutch ministry, but there are some contractors, there are some specialized IT firms that do smart stuff with data. There's the university, and there's world-class maintenance of course as well. These are slides from Angeline van Boxtel, who is the program manager for amongst others this particular area, and she shows us so far we have some. Her focus then was on the monitoring. In this case, this was the case. She presented this case at the World WCM Summer School last year. So basically, we have a couple of silos, monitoring silos, and even doing that will be better. But of course, those silos are interconnected. We silo the chain. We monitor the chain. We monitor corrosion. There is SCADA data we can use. There's energy usage we can use, and we try to combine those. One of the parties within that consortium is Mobilis, and this is Celeste Martes, also a former world-class maintenance summer school candidate, and indeed maintenance manager of the year last year. And she works at Kroon Wolters Mobilis, and they also are involved in specifically within this area, so there's this layer of circular design at the whole of, as Jacqueline tells it, as the example of the slice by Eefde, as Angeline describes it, and here's one of the parties within that project, as Celeste describes, and here's just an example of how the new thinking then translates into something really practical. 4 different types of battery and care systems to make sure that the power at this lock is secured, and 4 different options. And actually you see that the capex, the purchase cost of option 4 is the highest, and at the same time if you look at the life cycle cost, because the operating costs are so lower, it's the cheapest. So this kind of life cycle thinking typically wouldn't be done if if a company like Mobilis had as usual 5 or perhaps 10-year contract. It's just not, because then they are responsible for the purchase cost and not the operating cost. And now they are. And this is just a tiny example again in this layer of layered notion of circular design. What it means if you want to have a circular design in the end to a practical decision. You buy some smarter batteries. Also, Celeste stresses that this in this concrete example, it's really the interaction of technology, people and organization, and that as an ecosystem has to work very well. So circular design in public infrastructure is not just about the circularity of the physical infrastructure, but also the circularity of all the parties working together to make this a success. Indeed, a new challenge.